Just to add to what we did during the synchronous class, I want to talk about how we can use traces to help sketch these different figures. So in the first one here, remember when we're looking at traces, we're going to let each of our different variables be constant and think about the shapes that we get. So when x is constant, I get z is equal to some constant squared plus y squared. Right, so we should recognize that this is the equation of a parabola. So if I slice this in the direction perpendicular to that x-axis, I'm going to get a parabola. So if I look along a specific x value, I'm seeing that parabola, and it's getting moved up a height based on where I'm going. So when k equals 0, when I'm at x equals 0, I'm getting a parabola that's really far down. And I move up, I'm getting parabolas that are going up higher and higher in that x direction. Let's look what's happening in the y direction. In the y direction, when y is equal to a constant, I get basically the same thing. Y is equal to x squared, z is equal to x squared now, plus some y squared. So again, for different values of y, I'm going to see these parabolas that are getting up higher and higher in that y direction. So these parabolas are parallel to that xz plane. And depending on what y is, I just meant to make that y equal a k here. Depending on what that y is, my parabolas are going to be higher and higher. So I'm going to get these higher and higher parabolas each time. So if I slice in the direction of the x-axis, in the direction of that x equals constant, my yz plane, I get a parabola. And if I slice it in the other direction along a constant y, I get a parabola. But what happens when I slice it for when z is constant? When I replace z with a k, I get k is equal to x squared plus y squared. So that's going to give me a circle of radius k. So if I slice this in the z direction, I'm going to see these circles that are going to get a bigger and bigger radius as we go up. So we can try to put that together, right? We should see parabolas in two of the directions. We can see that circles going up. So that shape is what's called a paraboloid, because it has those parabolas going up. I'm going to see sort of this parabola that gets rotated around that z-axis. So I can see my z traces of circles, and then my x traces and y traces of those parabolas. Now let's compare that to z squared equals x squared plus y squared. So for that, when I have a z squared, if x equals constant, I get z squared is equal to that constant squared plus y squared. So z squared equals y squared, right? That's a little harder to picture what that's going to be. But if we rewrite it so we can think of it as z squared minus y squared equals k squared, that's going to be that hyperbola. So when x is equal to a constant, along this x-axis, I pick which constant I want. I'm going to get some hyperbola here. It's kind of weird to see. So let's see what happens for our other traces. Y equals a constant. It's going to look basically the same. Z squared equals x squared plus constant squared. So I'm also going to get those hyperbolas in that y direction. They're going to be coming down over time. When that k equals 0, I just get z squared equals x squared. Did not draw the right letters there. Let's fix that. Z squared equals x squared, or z equals plus or minus x. So that's going to actually give me those two straight lines. And the same thing will happen up here. I'm going to get these lines there at that plane. at that coordinate plane. Okay, finally, when c equals a constant, I get x squared plus y squared equals k squared. So that's a circle of radius square root, radius k. Over here, I should have had root k. So because that radius was growing like a square root, it wasn't growing as fast, so we got that sort of curved edge here. But now we can really see what this is going to be. At height k, so if I go up to a height of k, I should have a circle of radius k. I go up a little higher, I have a circle of that new height, and so forth. So the height is equal to the radius, so that's going to give me that cone shape. So these are our two basic shapes that we really need to know here. Our cone and our paraboloid. So what's their sort of defining difference? If you just have z equals this, think parabola, because I see either z equals x squared or z equals y squared, and that's going to give me the paraboloid. Here, if I have z squared equals x squared, that's going to give me those lines, and that could give me that cone. I can also sometimes write this just as z equals the square root of x squared plus y squared, taking the square root of both sides. But because I don't have plus or minus, this is always going to be greater than or equal to 0. So that just gives me the top half of that cone. So that's the other thing that's related to this that we might see. Okay, so let's go ahead and actually look at these examples in Geogebra. I've got a specific demo pulled up here, and I'll go ahead and share the link with this if anybody wants to try it. But what we want to do, let's see if we can get into here, and we can actually then change this shape. So the first one that we were looking at here was z equals x squared plus y squared, so x squared plus y squared. Click enter. We can see this is that paraboloid, and what it's showing us is that when y is equal to a constant here, for those different values of those constants, I'm getting these different parabolas that are going up and down on either side. If I change that to say z equals a constant instead, then we'll see those circles. So that's going to be my paraboloid. It's got circles one way and parabolas on the other way. And I can compare that to, let's see here if we can find our function. Here we go. So I compare that to the cone. We can change this to the equation of that cone. So I'm just going to change, see if it'll let me. Come on, be nice. We'll change that z to a z squared, and we'll say z squared is equal to x squared plus y squared. Hit enter. Can zoom that out to see that cone. We still have those circular traces in the z direction, but now if I change that to a y trace instead, then we can see that we don't get a paraboloid, but instead we're going to get that hyperboloid. So it's going to have that slightly different shape and have stuff both on the bottom and on the top there to get that hyperboloid. So I encourage you to play around with this trace demo, and again, I'll include the link next to the video. Let's try a few more examples. So for this one, we're going to do the same thing. I'm going to let x be a constant, then y be a constant, then z be a constant, and I'm going to think about what the shapes look like in each of those directions. So when x is a constant, I'm going to get 2y squared plus z squared. I'm just going to subtract that constant over to the other side. So I get circles. As long as this k isn't too big, so I'm going to get circles when absolute value of k is less than 2, because that way k squared will be less than 4, and that way this will give me a positive radius. I can't have this equaling a negative value. Oh, and I shouldn't have actually said circles there, right? Because I have the 2 in front of that y squared, but only a 1 in front of the z squared. So let's fix that. Instead of circles, we're going to get these ellipses. Okay, let's try to see what happens when y equals a constant. So I get 3x squared plus z squared is equal to 12 minus 2k squared. So again, I've got an x squared and a y squared equaling some constant. So that's going to give me ellipses. As long as that constant is greater than 0, so I'll actually show you where I got that absolute value of k expression last time. So I'm just going to solve this. 6 is greater than k squared, so k is greater than absolute value of k, because I'm going to square root both sides, is, that could be equal to 0 as well, less than root 6. And then finally, when z equals a constant, we get 3x squared plus 2y squared is equal to 12 minus c squared. So this again gives us ellipses when z is less than the square root, or equal to less the square root of 12. And here we should be a little careful. We want to think about this as a specific constant, not as z itself. So let me go ahead and replace that with that k. Okay, so this shape is going to give us those ellipses in all of the directions. So I've got a picture prepped for this guy. This is what it looks like. So in the x direction, let's move over the corner so doesn't cover too much. If I slice it in that x direction, I'm seeing those different ellipses. If I slice it in the y direction, I'm seeing those different ellipses. And I slice it in the z direction, I'm seeing those different ellipses. Let me go ahead and just draw those one more time because I want to color code it. So in the x direction, when x equals a constant, these are the ellipses we're seeing. When y is equal to a constant, these are the ellipses we're seeing. And when z is equal to a constant, these are those ellipses I'm seeing. So we get that sort of elliptic sphere, and that's called an ellipsoid. Okay, so let's do one more example where we use traces to help us visualize these shapes. So we'll do again our x traces. So x is equal to a constant. I get z is equal to a constant squared minus y squared. So that's going to be a downward parabola. So in the x direction here, I'm going to see this downward parabola. So at the origin, at x equals 0, I'm going to see this, and then it's going to be moving up some as we go out. But I've got those downward facing parabolas. When y is equal to a constant, I get z is equal to x squared minus that constant squared. So that's going to be an upward parabola. So even though I have downward facing parabolas in that x direction, when y is a constant, I'm going to be seeing these upward facing parabolas that start getting moved down over time. So maybe we'll start down here and draw that upward facing parabola. And then my z traces are going to be a constant equals x squared minus y squared. Right here I let z be that constant. So if k equals 0, I'm just getting x squared equals y squared, or x equals plus or minus y. So I should see those straight lines, x equals y and x equals minus y. When k is greater than 0, then I'm going to see this x squared minus y squared is equal to that positive number. So that's going to be that hyperbola. And it's that x hyperbola, so it's going to kind of be like this. But if k is less than 0, I should switch everything around. So I should have that y squared minus x squared is equal to negative k. Now this is positive. So that's going to be a hyperbola going in this direction instead. So I've got my two different hyperbolas for the two different z's, based on if that z is positive or negative. And I have upward parabolas and downward parabolas, all in this same picture. So the question is, what does that look like? It's this sort of saddle shape. It's called a hyperbolic paraboloid. You can kind of think of it as a saddle. So I've got my parabolas facing downward in this direction when I cut for the y's. I've got my parabolas facing upwards in that x direction. Oh, sorry, I actually switched those. This is a little weird because this is my x-axis and this is my y-axis. So the y guys give me those upward parabolas, which we had said, and then the x guys give me those downward parabolas, which we had said. If I cut with the z's, then I'll see these hyperboloids, and I'm changing which direction my hyperboloid goes, depending on if z is positive or z is negative. So we can think of this sort of as a Pringle chip or a saddle. Okay, so just to kind of go over all of the really important pieces here, these are the different shapes that you'll be expected to know throughout the course. So we'll get really used to spheres. And to recognize a sphere, you have an x squared, a y squared, a z squared. You have positive 1 as your coefficients, and then it's equal to some positive number here. So, right, we sketch that pretty easily. If we change it a little bit where we put positive coefficients in front of the x squared, y squared, and z squared, that'll just stretch it out in one of those directions. So that's how we get the ellipsoid. We're not going to see that many ellipsoids. We'll really see more spheres. We could also have our regular circular cylinder. So that's the one we'll see most common. But you should also get used to recognizing the other types of cylinders. So parabolic cylinders, hyperbolic cylinders. So those are just going to be a curve where you're missing one of the variables. And then you're going to draw that curve in the plane and then slide it out along the different axes. And the other big two are the the paraboloid and that cone or half cone. A paraboloid has z equals x squared plus y squared, and you should be able to know that basic shape. If instead of having 1 in front of the x squared and y squared, you get different numbers, it just makes it an ellipse instead of a circle, so you get an elliptic paraboloid. For the cone, I have basically the same shape as the paraboloid, but I have that square root instead. If it's written with a square root, that's just the top half of the cone, so I get that half cone. If it's written instead with z squared, then I get both the top half and the bottom half. So being able to tell the difference between this paraboloid and this cone, which is really whether or not the z is squared or not, that's going to be something that's important. So over the next couple of weeks, we'll see a lot of these, and you should get used to recognizing these same basic shapes.